Right, hello. So over this weekend, I have been doing some Sony PS4 stuff. So I've had a really horrible weekend so far. This is literally my high point, is talking about fucking data, because I love this stuff. I'm a technical programmer. That's different to a gameplay programmer. That's different, well, to what most people think of like making gameplay mechanics, and programming is making the person jump, right? I don't deal with that stuff anymore. I've transcended to another plane, also known as systems programmer as well. So when I see games, games are made up of these things and other things as well. I don't see this stuff anymore. I see data. I see numbers mostly, and occasionally some letters. I worked on this game for the benefit of people who don't know me. I worked on Untitled Drifter. I did database stuff. I did optimization and work in that regard, that kind of direction for Untitled Drifter. And I'm now working on the Swords of Ditto, which is being published by Devolver, and it's being released on the 24th of April. Please buy it. Woo! Yeah, the QA testing's gone really well so far. So hopefully it's going to be a good game when we release it. Today, we're going to learn how to make a save file. We're going to look at two methods. One is going to be really, really good. One's going to be really, really bad. And it's going to be like using an example that's bad to show you how to make it better again. Hyperlight Drifter did it the bad way, right? I didn't get around to fixing it because I didn't have time. Swords of Ditto, I learned from my experiences, and we did it the good way, and it is much more reliable. In fact, we've had no bugs since I implemented it back in October. Woo. So first of all, we need to talk about data storage in GameMaker. You have no idea how excited I am about this, seriously. Okay, even did animations, it's great. I think the first, the fundamental unit of data structures is arrays. Hopefully we'll know what an array is. I'll go over it very quickly in a second. And alongside arrays, we have DS lists, and we have DS grids. Now, you might not have seen these before, especially if you haven't used GameMaker before. Well, there's other things called DS maps as well, down here, and there's kind of other DSs. And DS stands for data structure. It's a generic term that GameMaker uses for stuff that's more complicated than an array. It's a way of storing data in a way that's more complicated than an array or more flexible. There are other ways of storing data as well, buffers and surfaces. But we're not going to really talk about those so much because I'm more interested in what are called tabulated data. So arrays, lists, grids, you can all represent them as tables of data. You can think of them like that. And down here we have DS maps and DS lists also form a little partnership of their own, which is called Json. I'll tell you what Json means in a second. It's very exciting. It has no bearing on anything in GameMaker, but it's really cool anyway. And we're not going to talk about these at all because they're way too complicated, way too advanced outside the scope of this talk. The data storage methods that these represent are interesting, so I do encourage you to look into them. So we're going to take it slow. First things first, tabulated data, 1D arrays. It's a column on a spreadsheet. People spend so much time talking about arrays, and they never do it right. It's just a column. You have a thing here, and a thing here, and a thing here, and a thing here. The array is the whole column, right? That's it. That's it. It's no more complicated than this. You can refer to each cell by using a number, which refers to which row it is of your column in your spreadsheet. But DS lists and 1D arrays are equivalent, right? So if you haven't used GameMaker before, you're not familiar with DS lists, you can think of them as the same thing as arrays. And in fact, that's how you deal with arrays, that's how you get data in and out. And DS lists look very, very similar. So we have the storage unit here, which is an array. We have a storage unit here, which is a list. Then we have the index I, also one down there. And then we have the input and output values. So they look very, very similar. In fact, they operate very, very similar as well. Notice I've used replace, not add, for people who use GameMaker. Replace allows you to refer to a specific element, whereas add just kind of sticks onto the bottom. 2D arrays are like 1D arrays. They're just a spreadsheet. Just think of it as spreadsheets. That's all you need to do in your mind. When you talk about theoretical things like, oh, it's pointers to information and you access the pointers, ignore that. It doesn't, care about it. Just think about it as 2D data on an Excel spreadsheet. And it turns out that DS grids and 2D arrays are very, very similar as well. Like 1D arrays and lists are similar, 2D arrays and grids are very similar. So here we go, that's how you deal with a 2D array. And that's how you deal with a grid. You can see that the XY coordinates, which is your rows and your columns, or your columns and your rows, work the same way in both grids and arrays. So since they're so similar, arrays and these data structures, lists and grids, you might be asking why we use them. DS lists and DS grids give you lots of extended functionality. It's really exciting what you can do with them. So exciting, I'm going to show you why. The thing is that arrays are great as well. They do have a use. But if you try to implement some of this stuff, it's kind of a pain in the ass, right? So here's how you put a value in the middle of an array. So if you've got this data here, and you're trying to stick it in the middle of an array, that's the code that you have to do to get it to work properly. And notice that I'm using this weird little @ symbol here, which is called an array accessor. Don't worry about that. This is complicated. You have to do that in a script, and it's manual and it's slow. If you want to do it with a list, it's one line of code. That's it. It's really simple, right? Okay, how do you delete a value from an array? You have this, you have 2 for loops, and then you can't even access change the array in situ, right? You have to return a new array and reassign it, which is really unintuitive and it's crap. And GameMaker's a real pain with arrays. DSList, it's one line of code. This is why we use data structures. So it begs the question, why bother with arrays then if data structures are that much better? The answer is data structures have this weird dark side that make me very uncomfortable and is the source of like 50% of bugs in Swords of Ditto. Memory management in Comic Sans for extra horror. I think this is best illustrated as an example. We're going to repeat this a bazillion times. We're going to create an array, fill it with data. This is a cool feature in GMS2, by the way. Get GMS2. You can create array literals. So you can just create an array in code rather than having to do like create the array and then assign each individual value. And then what we're going to do is take the array variable and assign to it undefined. What this does is it takes the array and it just dumps the memory, deallocates it. So GameMaker knows that you don't want to use it anymore. Now here's another example. Repeat it a bazillion times. Create a list, fill the list with data, get rid of the list. This doesn't work. It doesn't work at all. So what we're doing here is we're setting the array variable here to be undefined. So it's dumping that data, it's changing the data type. What's happening down here is that, oh, it's kind of hard to see actually, isn't it? What's happening here is that this variable here, list, is referring to a location that the list is stored. It's kind of complicated. So when you change the list to undefined, you're not changing where the list is stored over here, you're changing your reference to the list. So that means that that memory is still there. You've still got the list sitting in memory.
Basically the equivalent of taking a drawer full of stuff and just taking the label off it.
Precisely. That's a fantastic analogy. Now, we can get rid of the drawer. Oh, hang on. Data structures are like resources, like drawers. So for every data structure that you create, you have to destroy it. Otherwise, you end up with a memory leak. If you get enough memory leaks, then it crashes your PS4 builds and makes you really sad on a Sunday morning before you have to go give a talk. So the way you solve this is that you put in this wonderful line of code here, DSList destroy. That's it. So every time you use a create, you have to create a destroy command as well. So you have to create and then destroy. This will solve your data structure problems. Save files. I promised it, and now we're going to go do it. Save files require a bit of thinking first. So before you write complicated code, sit and think about it. Number 1, you slot the data into your DS grid, right? That's pretty straightforward, right? You've got a plan, you put your data into the grid. And the way we do this is we use 1 row per instance and 1 property per column. So if you think about it, we have each instance being a row, and then each property is then a column. It's like a spreadsheet. Rows, columns. Let's say the first column is the object index. Next one's the x coordinate. Next one's the y coordinate. Fine, next instance. Sits in a nice table. Beautiful, simple. And what we're going to do is once we've built this grid, we're going to use dsGridWrite, which is a really cool function. Not many people know about it, but dsGridWrite allows you to turn a grid into a string. So then what you can do is you can take the string and just stick it into a file. Just do a normal string writing function for a file. Now, as it turns out, secret spoiler warning, dsGridWrite doesn't work very well. So this function here is kind of trash. Unfortunately, it has a lot of bugs. So I ran into this, and the reason why we changed the save system for Swords of Ditto is because I ran into a bug with dsGridWrite, where in some cases you put data into it, and it would not be the same when you got the data out of it. So that really screwed everything up. That is a bug, though. That's not how it's intended to work. So imagine it does work. Imagine it's perfect. This is what our table looks like. It's a spreadsheet. Here's 2 instances of object tree. Here's another instance of object NPC. And then we've got some data over here for its x and y coordinates. Simple. Here's the code that does it. And I'll let you take that in for a second. All right, OK, that's some code. What does it do? All right, fine. Initialization stuff. Uses as a script. It's getting the file name, initializes the grid. Down at the bottom, turns the grid into a string, destroys the grid. destroys the grid. Very important. Always take care of your memory issues. So that's kind of bracketing the meat. This is the meat of the function. First of all, we're going to go to every save parent. So imagine an object inheritance system of some kind. We're saving all of these objects. We've got this iterator variable, I. And every time the loop completes, it iterates. And what this does is it means that this variable over here, not sure you can see that necessarily on the camera, but there's I over here. So for every time you go through to another instance, it goes to a new row. First line of code, or the first pair of lines of code here, is that we get the name of the object, and we stick it into the grid, column 0. Then we get the x-coordinate, stick it in column 1, and the y-coordinate, column 2. It's easy. It just makes this. Man, that was great, isn't it? Like, look at this. This will save your entire game. That's it. Fortunately, it doesn't work like that because it's total crap. It doesn't work. It doesn't work because anytime you do something more complicated that needs more than just a few variables, let's say you want to save an array, you just can't do it. It doesn't work. You end up with this really complicated system where you're getting arrays and sticking them in different places and trying to refer back to them, and you tie yourself in knots to solve a problem that was in the inherent in the design stage. So here's some key issues. If format changes, you're screwed. So if column 1, you decide no longer needs to be the object name, it needs to be lines of dialogue, the whole thing breaks. If you have different objects that need different properties, you'll end up putting variables in different locations which might have different meanings and different contexts, and that is a nightmare to debug. And finally, dsgridWrite doesn't support nested data structures. So you can't go back to this table here and put in arrays here. You can't make this an array. You couldn't make this a list. You couldn't make this a grid within a grid. So if you're trying to represent complicated structures that have depth to them, like a game does, you just can't use this basic method. So there's got to be a better way. Okay, it's JSON. This thing, it's incredible. It's going to change your life. Well, maybe not, but it changed my life. Okay, so JSON exists down here. JSON is a pairing between a DS list and a DS map. We've done DS lists. Remember, they're 1D arrays. They're like a column of data. DS maps are way different. DS maps kind of blew my mind when I learned about them. These are called hash tables or dictionaries for people who are familiar with those. So we can think of a list as data in a nice line, and they go sequentially. So 0, 1, 2, 3, 4, 5, 6. You could turn that into a dance if you wanted to. Maps look like this. They look like slight rendering bugs that were not on my computer at home. Maps are unordered. They kind of happen in a pile. They happen in a puddle. The way that maps work is that you have keys that are associated with values. So every key has a value. Key, value, key, value. Right? Yeah, right, yeah. I can't bake for not good at cooking. Take pictures if you like. So you have keys and you have values. Fine. DS maps are unordered, though. So the order in which you have your data, you know, up here we have baking skills down at the bottom where they deserve to be, and then my name at the top where it deserves to be. It doesn't matter which way around you actually put these things. And you can find these data, this data stuff, by looking at strings. So you go to the DS map and you say, I want to find what job Julian Adams does. He does a job. It is Game Maker. Nice and simple. So it actually turns out that you can have your data like this, or like this, or like this. And it doesn't matter. These are all the same. It's all the same DS map. In fact, when you put stuff into a DS map, you have no way of knowing what order these things are actually going in, which is really interesting. Sounds not useless, but it sounds of limited use. It turns out, in my opinion, this is more useful than a DS list, by far. I'll tell you why. But first, this is how you use them. This is how you put stuff into a map. So you add to the map, you add your key and your value. And when you want to find stuff, obviously you only need the key, so you put the key into the function, and it gives you the output value. Also, DS maps have this wonderful feature where you can tell if a key exists in the DS map just by looking at the key itself. If you want to do this in a list, you need DS list find index, for the people who know this. And if GameMaker can't find your value in the list, then it says -1, rather than a normal value. It just tells you -1. The thing is that if you need to find something in DS list, it needs to go through every element. That is what we call ON complex. That means, at worst case, it needs to go through every bloody element. In a DS map, it is O1 complex. It only needs to look at one entry to see if something exists. This is handy. So DS maps I've seen used by many, many people, and I've seen them used wrong by many, many people. So here's some guidelines so you don't do the same things. Make me angry. Keys should always be strings. GameMaker lets you make keys for DS maps, not strings. Please don't do that, because it means that if you try to debug it, you have no idea whether a string is meant to be a string or a number. And when you serialize things using JSON, spoiler warning, if it has, you're going to say a point in a second. No, okay, fine. So if you serialize something into a JSON, it makes everything a string. So if you expect it to be a number and it turns out to be a string, you're going to have to debug that. So just make them all strings anyway. It's more useful if they're all strings. Try to avoid iterating over a DS map. I told a little white lie earlier. You can actually tell what order stuff goes in, but it's incredibly slow. I think it's O n log n, off the top of my head, it's complex, which is really bad. So try to avoid iterating over DS maps. If you have to, you have to.
It should be ON.
I can't remember. Maybe it's O.
You're doing it wrong if it's O log n.
It's GameMaker, man. I'm gonna be honest. I don't know what they're doing with the hash table in the background because they're allowing you to use real valued keys for your dictionary. I have no idea what they're doing in the back end. So I'll have to go ask Mike Daly, and he'll tell me to go away, I'm sure. That's going on record, isn't it? Yeah, hi Mike. Yeah, I won't go that far. So DS maps are not a replacement for tabulated data. So you can't use a DS map, or you shouldn't use a DS map to replace a list or a grid or a array. Because as soon as you try to remove an entry from the middle of a DS map and you expect all the values to still be sequential, it isn't going to work anymore. And finally, I've seen people do this, and I've tried to do it myself. Do not make them replacements for actual objects and instances. You can do that, because if you... Oh, I'm not going to go all the way back. But you can... All right, Json, come in. So you can, since each value you can look at as a value of a variable, and each key you can look at as the name of a variable, that means you can kind of simulate an instance by using the keys as variables. Each entry in the DS map is a variable. Don't do that, because it's really slow. It's way slower than actually using instances, and it's really complicated. Anyway, JSON. Yes. Does it loop forever? I hope it does. JSON stands for JavaScript Object Notation. So this is an industry standard thing, mostly, that web services especially use to communicate data to each other. It's very, very compact. It's very, very nice. And obviously, we don't care about the name because we're in GameMaker. So JSON is a way of expressing data as a tree rather than as a table. So this requires a bit of imagination. Because we've been talking about kind of, tabulated data, like flat things that you can kind of imagine, kind of playing around with, JSON's a bit more complicated. It's still okay, because even I can make diagrams of this. So this is tabulated data. Everything's nice and neat and ordered, and as soon as you take away this row comes across, or column rather. And it's kind of nice, right? JSON is much messier. JSON would look like this. Par exemple. This is some kind of JSON thing, so stuff branches, and things can have different amounts of data, and you can branch again inside of a branch, and this can go on infinitely. You can have this infinitely deep JSON. Some people have used JSON as a way of making virtual machines, incidentally. JSON tree, for us, not for the other people in the world, for us, are made using DS maps, DS lists, nested inside each other in some way to describe whatever you're trying to describe. So if we look at our DS map from before, I'm going to put some more information in it using some lists and using a DS map. So this here is the original DS list. This is what we had originally. And then inside each one of these keys, I put another list, put another list, and I put another map. And you can do this infinitely. You can keep going for as long as you want. And this allows you to do some really interesting stuff. So let's say you want to have a list of all of the instances, and then instances have children. And then the children have links to other things inside of your structure. You can do all of that with a JSON. You cannot do that with any other data type, really. Or at least you'd have to come up with some crazy format. You might as well just use JSON. So if we're going to look at this particular structure here as a JSON, it would look like this. So this is my name, this is my age, this is my job, this is what else? Yeah, my hobbies, and this is my skills. Once you start thinking about stuff, data, as trees, as JSONs, you start seeing how to lay this stuff out for stuff like save files. GameMaker gives us some native functions, and a quick few words on these. These are the only functions you need to know for using JSON beyond the dsmap, dslist stuff. Unfortunately, whoa, what's going on here? Man, that's not like, oh. Anyway, never mind, ignore this. No, this stuff doesn't exist. These functions down here are kind of broken, much like the sliders. These functions don't really work the way you expect them to. This is much more natural. You put stuff into a map and you know what type it is. These ones, for some reason, these two down here, work a little bit differently for some reason. I don't know why they were made like that. And also, this function JSON encode only works if you've got a dsmap as the first element in your node. If you have dslist, this doesn't work so well because of the way GameMaker does stuff internally. Anyway, fun fact, you can clean up data structures really easily. This here, you've got stuff nested inside stuff, and then you destroy it, and it all disappears completely. It all gets memory managed for you. So JSON is cracking. Means you don't have to worry about any memory issues. Ooh. Did you load up the ODT version or the PowerPoint one? Weird. Anyway, this is meant to say serialization part 2. It was a really good joke, and it's totally blown it. Anyway, so let's start with a DS list. Let's think about this. We've got our game, it's full of stuff, right? I've got our room, it's full of stuff. Let's make a list of all that stuff. And each thing that we find in our room, we're going to add it to the list as a map. And we're going to have one map for everything that we find, for every instance that we find. And then inside the map, we're going to have each variable is going to be a key, and each key's value is going to be the value of the variable that we find. And that describes everything that we'd want to save. You could even do this with lists. So we could find lists in instances and attach them to our DS map, and it would still serialize because that's how JSON works, right? You can put a list inside a map inside a list. So it's going to look like something like this, where each group of data is an instance. So each one of these is an instance, and each circle is a variable. It's nice and easy. Also means that if we need to have different amounts of variables, different amounts of entries for each instance, we can do that. Just add more stuff on. If we need to nest it in a different way, if we need to put more information in it, you can just do that. Totally natural. Let's do it. Let's make this system. Let's create a list. Then we're going to iterate over everything. And for everything, we're going to make a DS map. Then we're going to add that to the list. And then we're going to make sure that GameMaker knows that the thing that we just entered, which is the size -1, 0 indexed, going to make sure that that GameMaker knows that's a map. And then inside that map, we're going to put an object, its name, which we get from this function here, object get name. You're going to put its x coordinate and its y coordinate. And that's going to do everything in the game. And then we need to do some faffing around because, as I said, JSON encode doesn't like lists as the first node. So we're going to do it with a wrapper. So we're going to put all of this data we just found, you're going to put it inside a map. Then we're going to kick out everything as a string. Then we're going to put the string into a file. I've kind of hand-waved this a little bit. I'll show you that script later. It's very simple. And then, what's the most important step? Destroy the data structure. Make sure we destroy the map wrapper. And because we have because we have placed the list inside of the map, that means when we destroy the map, it destroys the list, then it destroys everything that's inside the list as well. That's it. Admittedly, this is a little bit more complicated than the grid-based version. But this is really flexible. This is great. This will take you far. This is how sorted ditto works. How does this help us? So going back to the 3 points that we raised about tabulated data, about DS grids. If the format changes, all our files are immediately useless for DS grids. Well, for JSON, it doesn't matter because the context of each value is stored in the data file. It's stored in the save file. We know exactly what each instance holds because we're told that by the key. It's fantastic. So we can just do whatever we want with the JSON. This is way better than a grid. What about different objects and different setups that we need? Well, for a DS grid, we need to do that with special cases. Still kind of needs to do that with JSON. But we don't need to worry about the size of the grid or like how to best pack in our data to make it more efficient. We don't need to worry about like how to organize it, make sure that it's clear and unambiguous. And we just don't need to do that with JSON. It just solves that problem instantly. And finally, DSGrid write, which as we know has a bug, but DSGrid write doesn't support complex data. Well, with the JSON, do whatever the hell you want to nest stuff, as long as it's a DS map or a DS list, so you don't need to bear that in mind. But you can do whatever you want with the JSON. And if you have any arrays, you'll need to turn them into lists when you put them into the data structure. If you have grids, you need to do a list and then lists coming off the original list, and then you can serialize that as well. That's it. JSON solves all of the problems with DS grids, and it does it in a way that is, frankly, kind of about the same amount of code. So in conclusion, as I'm sure you've all worked out, I really like data. And JSON is way better than DS grids. This was 88 slides. Well done for sitting through it. Thank you very much. I'll put out the slides so you can have a look at the scripts. Thank you.